Hey, good morning, guys. Here we go. May the 5th. Happy Cinco de Mayo. What does that mean? Go out? Not go out, but hopefully you get to enjoy some tacos or nachos or something. Celebrate, some history to our neighbors in the south or south of us. Anyway, happy Cinco de Mayo. We're going to continue to write our CERs today. Which are our explanations, our claim, evidence, and reasoning. There we go. And so your target's the same today. You're constructing an explanation. You're going to be taking and thinking from the rocket and developing questions. We did that yesterday, and we're going to move that to a claim, evidence, and reasoning model. Yesterday, you went ahead and put in what you felt were pieces of evidence, as well as your claim. Here's your task for today. You are to watch this video. Check. Done. Nice. Look at this slideshow. Almost done. Be sure your evidence section is complete. That should say your, not you. Be sure your evidence section is completed in your doc from yesterday. So I'll show you how you're going to have to go back and unsubmit your doc and add into that. Simply because I don't know how to reattach that doc to today's assignment. I don't know how I can take that same doc and move it to today's assignment. I can try, but if it doesn't work, you're going to have to go back and add on to yesterday's document. Review the scientific principles sheet that I give you, and choose the one that you think fits your claim the best. Don't get too overwhelmed with it. Just pick one that you think is the best. Or fits the best. Again, this is about the process of writing an explanation and not necessarily about you being perfect in all this information. Add the principle to your doc and turn it in again. So today is about just moving the next step. Then tomorrow, of course, you're going to add in where you'll put it all together in one paragraph, like a fluid paragraph. Other things for today, have a wonderful Tuesday. I want you to get outside, notice some things. The trees are starting to bud. That means leaves soon. The grass is growing. You got flowers. If you just go outside and take notice of some of these things and be grateful in that. Take a deep breath. Know that you can do this, and we're going to keep carrying on. We've got, another month to go here. And then you're done for the summer, and we can all kind of relax a little bit and sort of think about what this will look like next year. Okay, so here's what I mean when I say go back to your document. So you're going to have to go back to your classwork from yesterday on the stream. Either way you want to do it, you can go to your classwork or not. And the document we're talking about, of course, is this one, the how many fins on a rocket, where you could do your evidence. So that looks like this. We added in the how many fins best stabilize a rocket, and then you made a claim. First, you went ahead and did a little bit of evidence, and so you went and made a claim, and that claim, if my claim were 3 fins will best stabilize a rocket. Whoops, sorry. Ooh. All right, so I have a very easy claim. Notice I put due Monday. Today I'll put down here due Tuesday. And then you added in 3 pieces of evidence that you found. So in efforts to refine that, what I did, so anybody who didn't get this assignment done yesterday, or anybody who felt like, man, I really struggled to get evidence in there, I went ahead and and I'll link these. I took images of everybody's evidence. So here's pieces of evidence. Here's one example of, there's 4 sets of these. 4 makes it go slower. That's kind of a vague evidence. We need more. Drag would be reduced by 25% with 3 fins. If you had 4 fins, you take it down, that's 25% reduction in drag. That's an interesting concept to put. If there's 3 fins, there's interference drag reduced by 25%. In other words, drag is the friction against air. 4 fins is good because there's drag, but there's more stability. So there's interesting arguments here. Let's see, go to another one. Need aerodynamic lines. 3 should be good amount because it doesn't cause too much drag. Most I see have 3 equal number, so better landing. Another reason because there's less stability. So there's 4 sheets I will post. These are just screenshots that you can use for evidence. So again, then you are to, let me close these down. You are to add those into your evidence boxes if you have it. Or if you go on your Google, if you go on, you realize like, hey, wait a minute, my evidence isn't that great. I can use some of these pieces of evidence from these sheets. So step 1 is to go back, use these docs that I'll link to today's assignment, and then revise those evidence boxes or change them if you need to do that. Now the next step in writing an explanation, once you make a claim based on some evidence and you provide that evidence, if you really want to impress me, write down whether your evidence is qualitative or quantitative. Is it based on observation with our senses, or is it based on measurement? And then the next thing is to do the reasoning portion. And if you recall, this is the hardest part. This is the hardest part. And today we're going to rewrite all this and put it in there. So your job today, and you can do this 2 ways, is I'm going to provide another document for you. It's the scientific principles from the physics unit. And there's a bunch of them. If you look, you got 13 principles. So now I have to think, okay, I made a claim that 3 fins is better than 4 on a rocket. Now I'm going to have to go through and decide which of these principles, these scientific ideas that are accepted no matter what, which of these fits my claim that 3 fins are better than 4. And I got to base that on the evidence. I mean, a lot of evidence, like 25% reduction in drag, more stability, every 2 objects. So I'm going to look through them. Every 2 objects that apply a contact, all forces come in pairs in opposite directions. The motion, beginning of motion, I always call it object's motion influenced only by forces that are applied to it, not forces that applies to others. Forces that are applied to an object in opposite directions counteract each other. That's interesting. For every force, there's an equal opposite force. Dynamic friction always acts on an object against the direction in which the object moves. So there's 13 rather, you can pick from. Just make sure you're picking one that makes sense. So then after, let me get us back to here. After doing, revising or filling in, these evidence boxes, then you need to just type in the scientific principle. There's a reason I did it that way, that it just says scientific principle in this box. That's it. Finish the evidence boxes, type in the scientific principle, turn it back in. So then your organizer, your front organizer should have your claim, your very basic claim based on our question, legitimate evidence that you either found online and put in yourself, or evidence you found from the sheets I'll provide today. Again, that's the ones that look like this. They're just screenshots of the Google form. And then you're picking a scientific principle that best fits from this list, right? And actually, if you want to look elsewhere, you can. If you want to look like scientific principle that fits rocket fins or something like that, I'm always impressed when you guys are able to do searches that make sense to what you're doing. That's all you have to do today. So you're supposed to do about 20 to 30 minutes of each class a day. This video alone is going to be like 10 minutes. So then, that leaves us at the idea of, you spend 10 minutes or so on this, just making sure this is quality, guys, not just turning it in. All right, and then tomorrow, so you know where we're going, and this is not the page that you're going to mess with. Tomorrow, we're going to go back to our documents again, and we're going to write a scientific explanation. We're just going to put all this together in a paragraph that's fluid and makes sense. Okay, I hope that makes sense in terms of what you're supposed to do today. Let me see if I can figure out where